y minus iota x divided by x to the power 6 plus y square, where z is non-zero and f of 0 equal to 0. We have to prove that fz minus f0 divided by z, it is tending to 0 as z tends to 0 along any radius vector, but not as z tends to 0 in any manner. That means it is tending to 0 along only the radius vector. Otherwise, it is not tending to 0, right? This we need to show. So this is the function given to us, and we need to find this, writing limit x, y tending to 0, 0, because our function is in x and y, right? So writing here x, y tending to 0, 0. Z is the complex variable which can also be notated as x, y. So writing fz, x cube y into y minus iota x divided by x to the power 6 plus y square minus f0 is 0, it is given to us, divided by z. I'm taking z to be as x plus iota y. Is it okay? Fine. Alright, so this is equal to limit xy tending to 0, 0, and writing here x cube y. Alright, the coefficient of y is 1, right? Can I write 1 to be as minus iota square into y minus iota x? And then if I take negative iota outside of this bracket, I will be getting plus iota over here, and here I'm getting just plus x, so that it becomes x plus iota y, right? Divided by x to the power 6 plus y square. Why I have done this? So that I can cancel x plus iota y from the numerator and also from the denominator, right? So we are getting limit xy tending to 0, 0 minus iota x cube y divided by x to the power 6 plus y. Please mark this as 1. And now let's take this limit along the radius vector. So letting z tending to 0 along the radius vector, I'm taking y equal to mx, where m is belonging to the set of real numbers. Then we get, this is along the radius vector. If I put here y equal to mx, then we are taking the limit for x tending to 0, because when I put y equal to mx, everything will be changed into x. So this is minus iota x cube, taking y equal to mx, I get mx over here divided by x to the power 6 plus m square x square. And in the numerator, I get x to the power 4. Now taking x square common from the numerator and the denominator, I get minus iota x square into m divided by, from the denominator also taking x square common, so this is x to the power 4 plus m square. Right? So these two cancelled out. And when taking x tending to 0 on this, we are getting this to be 0. So that is, we have found that this limit along the radius vector coming out to be 0, right? Let's take this limit along any other curve. So letting z tends to 0 along the curve, let's say y equal to x cube. So from 1 we get, if I put y equal to x cube over here, everything will be changed into x. So writing here limit x tending to 0. So this is minus iota x cube, and writing y equal to x cube over here divided by x to the power 6 plus this becomes x to the power 6. So this is also nothing but x to the power 6. So if I take x to the power 6 common from the numerator and the denominator, I'm getting minus iota divided by, this is 1 plus 1, that is 2. So these two cancelled out, and we are getting this to be limit x tends to 0 on minus iota divided by 2, that is equal to minus iota divided by 2. There is no x. So that means this limit is equal to minus iota by 2, which is not equal to 0, right? So we get only this limit tending to 0 for the radius vector, right? If I take z tends to 0 along the radius vector, then only we get this limit to be 0. So hence we have shown this result for the radius vector. Okay, thank you.